All right, so for lesson 7-6, let's start out with just this idea of what is an inverse sine or an inverse cosine or inverse tangent. So they define it as this in the book. So y equals the inverse of x if and only if x equals the sine of y. So let's say, for instance, somebody says, I have the arc sine of 1/2 equals y. So how would I solve for y? So I could say, okay, first of all, this is the same thing as saying inverse sine of 1/2 equals y. These are the same statement. So this is the same thing as saying I'm going to find the sine of some angle, and that's going to equal 1/2. So the sine of what angle gives me 1/2 is what I'm looking at. So you're still looking at your unit circle like we normally would. So hopefully you can kind of get this backwards idea down. Okay, so the other thing I wanted to mention, so we have these domain and range values here that we have to pay attention to. So with sine, my domain can go from -1 up to 1, and my range can go from -π/2 to π/2. So typically it's the range we need to worry about, but sometimes that domain comes into play as well. So this kind of is a good visual of it. So this is my graph of sine. This is my graph of arc sine or inverse sine, and this right here gives me that range and domain very clearly. Okay, and then on my unit circle, what does that mean? It deals with this right here. So I've got from 0 up to π/2 and from 0 down to -π/2. That's the section I'm thinking about. So I'm really thinking about quadrants 1 and 4. Okay, inverse cosine or arc cosine. Same idea. So the difference here on this one is that my range value goes from 0 to π. So then I'm thinking about from 0 up to π here. And then tangent, kind of the same idea here. The difference on this one is the domain is any real x. So any value going this direction and this direction. But again, -π/2 to π/2 is my range right there. Okay, so then you talk about those properties. We talked about these yesterday in class. So here's those properties. So we just need to be careful whenever we're dealing with something that has a sine and an arc sine in it. We need to pay attention to these properties. Same thing with cosine and tangent. All right, and then let's look at some examples here and see what we can do here. Let me fix this so you can actually see the paper. Okay. All right, so this first one is asking me about the inverse sine of -1/2. So if I'm looking at my unit circle and I look at negative where sine is -1/2, remember sine is your y value, so I'm talking about this piece right here, so 11π/6, or I'm talking about this piece right here, which is 7π/6. But with those properties, I know I need to just think about these two quadrants. So this one doesn't really mean anything to me. This one does. But again, it has to be between -π/2 and π/2, which means I need to think about this as -π/6. So in this first one, I would probably kind of sketch out, okay, I need to be thinking about this, and on my unit circle, that puts it there. So this one ends up -π/6. You probably will not have any work for these. It's just kind of working through that in your head. Okay, so cosine, again, if I'm thinking about this one, I'm thinking about from 0 to π. Where is it -π/2? That happens over here. So again, if you're looking at your x values, right there is -√2/2. So I'm thinking about 3π/4, and that is within this range. So I can just list it as is. So 3π/4. Okay, when I'm dealing with tangent, I have to think a little bit more about where that is, because I have to think about it as sine over cosine, but I should still only be thinking about these two quadrants. So where does it happen where you have a negative, say the same value, sine over cosine, so that way it gives me 1, but 1 is negative and 1 is positive. So that's going to happen down here. And so if I want to name that correctly within my range, that would be negative pi over 4 rather than 7 pi over 4. Okay. Part D here, this one it lists it as arc sine of pi over 2. That's the same thing as saying this right here, sine of negative 1, negative pi over 2, sorry, just pi over 2. This right here, this does not mean that this is sine to the negative first power. It means it's the inverse sine. So when I just said sine of negative 1, I really shouldn't have said it like that because that seems like I'm saying it has an exponent of negative 1. So that's the wrong way to say it. I need to say it's the inverse sine. Okay, so arc sine and inverse sine, same thing. So this one, they're trying to trick me here. This should not be the angle that I'm talking about. This is one of those coordinate values. So I need to divide this and find out where that is on the unit circle. And if I do that, I end up with about the arc sine of 1.57. That's rounded for sure. The problem is my domain values have to be between negative 1 and 1. So if I go back to my, let me find it here. Here we go. If I go back to this, if I'm talking about arc sine, or sine in this case, inverse of sine, that x value, whatever you're taking the arc sine of, this has to be between negative 1 and 1. But in my problem, it's 1.57. So that's out of that domain, which means this is not defined. Okay, so this one, again, they gave me a coordinate value that's in terms of pi, so I need to divide that out. So this is really the arc cosine of, when I divide that, I get 1.05, which again is out of my domain value. So again, if I'm looking at cosine this time, my domain value goes from negative 1 to 1. This one is 1.05, so this one is also not defined. Okay, last one, arctangent of negative square root of 3 over 3. So now I have to think kind of critically here. Where is, when I do take my sine divided by my cosine, how am I going to get this, right? So if you look, remember, if you're thinking about, let me put it down here. If you're thinking about tangent, you're thinking about quadrant 1 and quadrant 4. So if I look at my unit circle, I'm thinking about these two quadrants. This one is definitely not going to get me that. And this one down here is definitely not going to get me that, because when I divide those, I'll get 1, right? Or negative 1. In this case, I wanted, was it positive or negative? A negative square root of 3 over 3. So that takes out these two options because there's no negatives. So I'm down to these two right here. Got a 50-50 chance. So the question is, should I be taking 1/2 divided by square root of 3 over 2 or square root of 3 over 2 divided by 1/2? Which way is that going to get me my square root of 3 over 3? So I'm just going to kind of sketch it out here. If I take, let's do the first one. If I take negative 1/2 and I divide it by the square root of 3 over 2, that means I'm multiplying by 2 over the square root of 3. So you flip and multiply, right? So that's going to get me, that's going to cancel, and that's going to give me a negative 1 over the square root of 3. So this doesn't look like this, but remember I have a square root in the denominator, so if I multiply by the square root of 3 on both the top and bottom, I get the square root of 3 on top, square root of 9 on bottom, which is 3, and it was negative. So this is what I needed. So I needed this 11 pi over 6. Or if I'm thinking about it in terms that are within that negative pi over 2 and positive pi over 2, this would be negative pi over 6. Okay. All right, this next part, I love these. These are the easiest ones to do. So if you look back to your properties, let me look right here. So when I'm dealing with my properties 1 and 2, so let's talk about sine first. If I have the sine of the arc sine of something, so if I take the arc sine of some value and then find the sine of that, that's just going to give me x right back again. Okay, and that's only true though if I'm between -1 and 1. So we need to pay attention to that. So in this one, 2/3 is between -1 and 1, so that does fit that profile. And I am taking, this is property 1, I'm taking sine of arcsine, so sine of arcsine. Okay, so that means this is just 2/3. That's the easy part. This one also fits between -1 and 1, so let's look at cosine, make sure it's the same, between -1 and 1. And again, here's my rule, cosine of inverse sine gives me x right back. So cosine of inverse sine gives me x right back. So this is -1/5. Tangent, we've got the same idea here. So tangent is true in this property 1, it's true for every x value. That is really important to note. So the tangent of the inverse tangent gives me x right back for any x value. So this one was not within -1 to 1, but it doesn't have to be. This just ends up -9. Okay, then let's move on to these. So when I'm looking at this value, and when I'm looking at sine, where I have inverse sine of sine. So inverse sine of sine. Here's my rules. I can get just y right back if it's between -π/2 and π/2. So when I look at this one right here, 2π/3 is not in that. It's bigger than 1/2 pi. This is 2/3 pi. So because this right here, I'm going to write it as it is out of my range, then I need to think about, okay, how can I then solve this? Well, if I go back to what we were doing in the first couple examples there, I can take this, find that value, and then do the inverse sine of that. So first thing I do is take the sine of 2π/3. So find your 2π/3. Your sine value there is the square root of 3/2. So I have the inverse sine of the square root of 3/2. That's what that equals. And then I'm going to simplify that even further. So now I'm looking for the sine of what gives me the square root of 3/2. So again, whenever we're thinking about this, we're still thinking about this idea of from here to here. I'm doing an inverse, right? So I got to be in one of these quadrants. So over here, I'm looking for, what was it? Square root of 3/2 for my sine value. So that would be right here. Down here, it's negative, so I don't want that one. I want this one. So π/3 is that answer. Okay, this one, same thing. This is not between, right here, I've got in cosine, it has to be between 0 and pi, remember? So between 0 and pi, does this fit it? No, because this is 1 1/3 pi. So that's too big. So this is out of range. Okay, so that means I'm going to have to find this first. So this is going to equal the inverse cosine of whatever this is. So cosine of 4π/3. If I go right here, 4π/3. Cosine is -1/2. So now I'm taking the inverse cosine of -1/2. So the cosine of what angle is -1/2, and it has to be within my normal range, so from 0 to pi. So I'm looking for my y value, or sorry, my x value to be -1/2. In this case, it would be right here at 2π/3. Okay, tangent, inverse tangent here. I'm going to start with this guy right here, so 7π/6. So up here, that could be any value. If I had tangent of the inverse tangent, this could be any x value. On the other hand, if I'm looking at the inverse tangent of tangent, that has to be within this range, -π/2 to π/2. So when I'm looking at this one, does that fall in that range? No, it does not. So this is also out of range. So I'm going to find this value first. So tangent of 7 pi over 6. So let's find 7 pi over 6 first. It's right here. And I'm going to do tangent. So that means I'm going to do negative 1/2 divided by negative square root of 3 over 2. So negative 1/2, I'm going to write it right here. Negative 1/2 divided by negative square root of 3 over 2. That means negative 1/2 times negative 2 over square root of 3. So these will cancel. That's going to give me positive 1 over square root of 3. And if I multiply both of those by the square root of 3, I get the square root of 3 over 3. So this is the inverse tangent of square root of 3 over 3. Okay, so then I need to look on my unit circle again, think about my two quadrants, just like with sine. So quadrant 1 and quadrant 4, and I'm looking for the square root of 3 over 3 to happen. Well, up here, when I was thinking about tangent, that happened when I took a negative, in this case, it was negative 1/2 divided by 2 over square root of 3. This time it could be 2 negatives or 2 positives. I'm just looking for a positive square root of 3 over 3. So sine was 1/2, cosine was 2 square root 3. So 1/2 and, oh, I totally messed that up. Oh, because I flipped it. So this was square root of 3 over 2. So 1/2 and square root of 3 over 2 happens at pi over 6. Or it happens down here in this spot right here, except this one's negative, so that's not okay. So it has to be this one, pi over 6. Okay, so let's stop there and I'll do the rest of the examples in the next video.